Okay guys, welcome again. We are beginning with question number 11. So if you're just joining and you have not watched the first two videos, then first video was question 1 to 6, second video question 6 again, because I introduced another method for question 6 to question 10. Now here we are going to solve 11 to kind of 17 or 18. Alright, so if you have not watched those videos, make sure after watching this video you go directly to those videos. It's very helpful. Comment section, I would love to see your comments, what you feel about this, if this is good, if it's helping you in one way or the other. That's what's going to motivate me to keep on making videos. Alright, so let's go to question 11. The coordinates of the focus of the parabola y squared equal to 16 into x plus 1 is. Alright, so generally if you have, let me say, y minus n all squared equal to 4a into x minus m, the focus is at a point m plus a comma and n. That is a focus. All right, so if this n is 0, in fact, why am I even going far? Let's go to the equation. My equation is y squared equal to 16 into x plus 1. So what is n? What is n? N is equal to 0, right? And what is m? M is equal to, remember here there is supposed to be minus, so we have negative m is equal to 1, right? We are comparing coefficients. Negative m is equal to 1, which means that m is equal to negative 1. And finally, what is 4a? 4a is equal to 16. Thus we have a is equal to 4. So the focus will be at a point, what is m? Negative 1 plus a is 4, comma, and then n is 0. So this is equivalent to this is 3 and 0. So 3, 0. Let's go back to the options. 3, 0, option D. Alright, so let's try to plot this parabola and see what we have. Y squared equal to 16 into x plus 1. Here is it. Y squared equal to 16 into x plus 1. Now let us locate the point 3, 0. What am I doing here? 3, 0. 3, 0. It's like this guy is mad. Let me do it again. 3, 0. Alright, it's really mad. Anyways, x equal to 0. No, x is 3. Pardon, x is 3. X equal to 3. Y equal to 0. So basically, this is a point here. So this is the focus of the parabola. Alright, that's the focus of the parabola. Alright, let's move on to the next question. So question 11, option 3, 0, option Z. Okay, let's go to question 12. Option first. Oh no, I will save this later. Question 12. Given that I minus 4k cross 2i minus lambda j minus k is equal to negative 4i minus 7j minus k, what's the value of lambda? So I minus 4j. So this is cross product of two vectors, so we just use a determinant method to get a cross product. So we just have to fill, we are in 3 dimensions, so we have I, j, and k. Now we have to impute the coordinates of the first, so we have negative 1, so I minus 4k, so it is the coefficient of I, the coefficient of j, and the coefficient of k. So we have 1, 0, negative 4. 1 for I, 0 for j, because there is no j, negative 4 for k. So we have 1, 0, negative 4. Now let's go to the other vector. We have 2, negative lambda, negative 1. So we have 2, negative lambda, negative 1, Now according to the result, I'll just put the result as a column in a column form. All right, the result is -4, -7, -1. -4, -7. Did I read well? I did. Okay, so what does this mean? Let's just multiply directly. Let's just do the cross product directly. So if we keep I, right, if we keep I, we'll be left with, like, we are covering this we are covering this first line, right, and the first line here. So we are going to be left with this 2 by 2 matrix here. So and we find the determinant. 0 times -1 is 0, minus negative lambda times -4 is 4 lambda. Now when we are going to the J component, we indicate a negative sign, we cover this and we cover this. We'll be left with 1 times -1, minus 2 times -4, -8. We now go to K, and then we cover and we cover. We have 1 times negative lambda is negative lambda, minus 2 times 0 is 0. So this is equal to this, okay, as it was given to us. Okay, so basically I'm just going to put the left hand side also in column form. So my left hand side, the first term here is -4 lambda. All right, that's a correction of I, -4 lambda. The second term, this is actually +8. When we add, we have 7. When we multiply with negative, we have -7. You see there is consistency because -7 and -7 are the same. So now let's go to the last part. This is actually negative lambda. All right, there we have -1. So we just have to equal corresponding entries. So -4 lambda equal to -4, lambda will be 1. -7 equal to -7, true. Negative lambda equal to -1, lambda is 1. So there is consistency, all true. It means that lambda is equal to 1. All right, so question 12, lambda is 1. Option A is correct. Option A. Question 13. Question 13. A linear transformation T is defined by this. The kernel of T is, so this is a linear transformation, and the kernel is just the set of all vectors whose images are 0. The kernel is a set. Okay, so let's give the formal definition of the kernel. So let's just skip down to question 13 down here. So the kernel is also called the curve of the transformation. It's equal to the set of some vectors, okay, in the vector space here. Our vector space here is arrow squared. That's a domain, it's arrow squared. The domain of the transformation is a vector space arrow squared. So the set of vectors in arrow squared such that if I take T of those vectors, I get the 0 vector. All right, so it is a set of vectors. In a nutshell, we are saying that if X, right, belongs to the kernel of T, it means that T of X is equal to the 0 vector. All right, now in this case, since my X is a vector in arrow squared, it means it has 2 components. All right, so X, I'm taking my time to explain. X is in the vector space arrow squared. It means that X is actually equal to a vector that has 2 components, I and J. So I can say X is equal to AB. Okay, so we have A and B, or AI plus BJ, right? Now let's do T of X. T of X will be equal to T of AB. Okay, T of AB. Now let's go back to the transformation given to us and define. So this transformation is just saying that T of xy is x minus 2y x plus y. So let me write its formal definition. T of xy is equal to x plus 2y. No, let's see if it's x plus 2y. No, it is x minus 2y, x minus 2 and x plus y, right? So this means that T of AB, because T of AB is equal to 0. That's equal to 0 0 because the 0 vector. Oh, what is this? It's equal to the 0 vector because the 0 vector we are talking about. If and only if, is that symbol? If and only if what happens? I need to replace x with a and y with b. If and only if I have a minus 2b, a plus b equal to 0 0. So what does this imply? We have two equations, all right? We are going to have two equations. So these two equations, the first equation is that a minus 2b is equal to 0, and the second equation is that a plus b is equal to 0. Now, if we subtract these two equations, a will cancel a. Negative 2b minus b is negative 3b equal to 0, so b will be 0. Since b is equal to 0 and a plus b is 0, it means that a is also 0 because a is negative b. So it therefore means that a is equal to 0 equal to b. Now, what is my kernel? Is a set, also the set of vectors. So the set of vectors 0 0. Like we said, it is a set. Alright, going back to the options, we take option B. Option B is correct. Alright. This option A like this option A like this is tempting me because we have just had one vector. No, we'll go option B. Yes, because kernel is a set. Alright, so option B is correct. Let's go to question 13. No, question 14. Question number 14. Which option is correct? Let's check out the question. Alright, given that we have a structure, the set is from A to D and the operation is star. They have given us a table and we are asked to find the identity element. So we just identify from the table. We know that the identity element is any element that if you multiply, if you operate with another element, you get that other element, as well as if you do the reverse operation, you still get back the other element. Alright, so the trick is that just come to the table and look for where you have A, B, C and D in that order. So you see here, let's see, voila, you have A, B, C and D. I have A, B, C and D. So D is the identity element clearly, because see, A, B, C and D going this way horizontally, coming vertically, A, B, C and D. The intersection of those two lines gives me the identity element. Now let's verify if we are true. If I take A and I operate with D, I will get A. It means that D is the identity element. Now let's go with B. If I take B and I operate with D, I will get back B. So if I take any element and I operate with the identity, I will get back that element. So if I take C, operate with D, I will get C, and the D itself operated with the D, I will get D. Now I think that's it, right? So D is the identity element. So question 14, option D is correct. How can they say the question and the option is the answer of the identity element? Very weird. Alright, let's go to question 15 up here. How many distinct solutions are there to the congruent equation? 12x is congruent. I think this equal to is a mistake. 12x is congruent to 15 mod 21. 12x is congruent to 15 mod 21. Hey, me too, I'm gonna make a mistake. Alright, so I'm going to convert this to a nice congruent equation. This 12, this 15, and this 21 have something in common. That thing is 3. So since they have 3 in common, by definition, I will divide all through by 3. Yes, possible, because they have 3 in common. That's just a principle. So this becomes 4x congruent, congruent, congruent. This becomes 5 mod. This becomes 7. All right. Now we need to find x. Okay. So x will be congruent to 5 times y mod 7. What is y? Y is a multiplicative inverse of 4 in mod 7. Now what is the multiplicative inverse of 4 in mod 7? It is a number that when we multiply by 4 and we divide by 7, the remainder is 1. The answer is 2, because 4 times 2 is 8. 8 divided by 7, the remainder is 1. So y is 2. When I multiply this, I get 10, right? And 10 mod 7 can be reduced. We just have to reduce it, because the remainder here is supposed to be less than the mod standardly. So 10 mod 7 can be reduced to 3 mod 7. Okay, so 3 mod 7, 3 mod 7. Anyways, so if you look at this, you realize that your x is congruent to 3 mod 7. True. But when we are checking for congruent solutions, we deal with the original mode, which is 21. So I'm going to convert this congruent equation into a linear equation. So if x is congruent to 3 mod 7, it means that x is equal to 3 plus 7 times a constant. Alright, this is a conversion. We take the remainder plus a constant, a multiple of the mode. So I'm just going to look for all values that are less than 21 and also positive. So when t is equal to 0, x is equal to 3. When t is equal to 1, x is equal to 10. We saw the 10 already even. When t is equal to 2, this becomes 14. This is 17. What have I written? 17. When t is equal to 3, this becomes 21. And it's already bigger than 21, right? So all of these answers are supposed to be in mode 21. So there are three of them, though they are infinite solutions, but we are interested in getting the distinct solutions, and the distinct solutions are basically gotten in the original mode. So here there are 3 distinct solutions. All right, so 3 here is option C. This topic is very, very crucial, so you not understanding, I'll not be surprised, but I just need your comment in the comment section. All right, let's go to question 16. The asymptotes to the curve y equal to f of x, where f of x is this r, x minus 1, x minus 1, x minus 1 plus the ln of the absolute value. What do we have here? We have x minus 1 and we have x minus 2. So first things first, we talk about the domain of definition. Now this function is the sum of 2 functions. The first function is a polynomial whose domain is arrow, so we don't care about its domain again. The second function is the Napierian logarithm, and for the ln to be defined, for the ln to be defined, what you are taking the ln of has to be positive and also has to be defined. You realize that you are taking the ln of an absolute value, so it is always positive already. All right, no matter what is in the interior, once you take the absolute value, the result is positive. So we just concentrate on defining the interior. For the interior to be defined, the denominator has to be different from 0. So the domain of this function, domain of f, is basically x. I'm not going to write in the interval. This wastage of time. It's paper 1. X not equal to 1, because if I say x minus 1 not equal to 0, x will not be equal to 1. Now let us, so this is already a vertical asymptote, because if I look for the limit at one from below and one from above, basically I will have plus or minus infinity. Alright, so x equal to 1 is a vertical asymptote. Now if you look for the limit at plus or minus infinity, the result will give you plus or minus infinity as well, because if you look for the limit at plus infinity, right, or minus infinity, what is inside here will give you 1, because we have a polynomial of degree 1 over a polynomial of degree 1. So, and the coefficients are all 1s, so what is inside here will give you 1. The ln of it will give you 1, so the ln of 1 will give you 0, and at the end of the day, the limit of plus or minus infinity will just be the same as the limit of f of x minus 1 at plus or minus infinity, which will give you plus or minus infinity. At plus infinity, it is plus infinity because this 1 is negligible. At minus infinity, it is also minus infinity because we are just replacing the x here with what it is turning to. So if this function is approximating to this function at plus or minus infinity, then this function is an oblique asymptote. Anyways, in a nutshell, if I take f of x minus x minus 1, I am going to have the ln of the absolute value of x minus 2 divided by x minus 1. Now by definition, if the limit of this answer here is equal to 0, then we call x minus 1 an oblique asymptote, and clear the limit is 0, right, because the interior will be going to 1 at plus or minus infinity, and the Napier logarithm of 1 is 0. So it means that the asymptotes are x equal to 1 and y equal to x minus 1 as the oblique asymptote. Alright, so x equal to 1 and y equal to x minus 1 are the asymptotes. Question 17. Oh, we have to check. Here's the last question for this series. So we have to check the option to question 16. Y equal to x minus 1 and x equal to 1. Wait. I forgot that the ln could be 0. I forgot that this interior could be 0. Very big mistake. We have to revisit our domain. Domain is x different from 1 and different from 2. Alright. I totally forgot that this man could be 0, because if the numerator is 0, right, then it spoils everything. So in as much as x minus 1 has to be different from 0, even x minus 2 also has to be different from 0, right? Because if x minus 2 is 0, everything here becomes 0, and if everything becomes 0, then the ln of it will not exist. Therefore 2 is not in the domain. So x equal to 1 and x equal to 2 are the vertical asymptotes, because when you get their limits, you realize that the limit as x tends to 2 will give you plus or minus infinity as well. Okay. Let's try to sketch and see what we have. Then we draw our asymptotes. Alright, here is it. Like we said, x equal to 1, we see x equal to 2. You see, these are asymptotes. If I try to expand, you realize that the graph does not touch. It does not touch them. Alright, so now let's draw the oblique that we had. Y equal to x minus 1. Voila, that is the oblique asymptote. So our answers are correct. Okay, so x equal to 1, x equal to 2, and y equal to x minus 1 are the oblique, are the asymptotes. So let's go back to the options. So x equal to 1, x equal to 2, y equal to x minus 1. Option D is correct. Option D. Now the last question of this series, last question is question 17. The statement x plus 1 equal to 3 is true for what is the value of x? X is equal to 2, right? So x is unique, so it is true for only one value of x. There is only one value of x that will satisfy this equation. So the answer is just one value. Option A says all real numbers, false. Option B says at most one value, that's false. It's not a quadratic or a cubic or a quintic or a quartic. Option C says at least one, it means that one or more, and option D says just one. Yeah, option Z. Option D. Since there was no much analysis here, we are going to do a bonus question 18. In fact, I'll just go to 20 here. Yeah, so that's at least question 18. Where are we? We are here. The function f is defined by this. Which of the following statements is true? F is odd. Now, this function is the absolute value function just by looking at it, because the absolute value of x is negative x when x is negative, is 0 when x is 0, and is positive x when x is positive. Is that function odd? The function is even always, right? Because where's my word? That definition is just x equal to the absolute value of x, alright? Because the absolute value of x is equal to, I think even Microsoft Word has a standard definition of the absolute value of x. Here is it. So here's a definition of the absolute value of x. Okay, so we could even, to have the three intervals, we are going to say that it is 0 when x is equal to 0, and we are going to say it is x when x is greater than 0. Alright, so that is it. Now, knowing fully well that this is a building block of this definition, let's look for f of negative x. F of negative x is the absolute value of negative x, which is equal to the absolute value of x, which is equal to f of x. Okay, so you see that f of negative x is equal to f of x, so the function is even. So f is even. Alright, so option A is wrong. It is discontinuous at x equal to 0. False. In fact, option C is correct already. No need to even bother. But why is it discontinuous at x equal to 0? Let's talk about continuity. Then now we can deduce discontinuity. If a function is continuous at a point, then the limit at that point exists, and that limit is equal to f of the function is equal to f of the point. Alright. The limit at 0 exists if the limit from below is equal to the limit from above. So the limit as x tends to 0 from below is 0, because you are just replacing this x with 0. If you are tending to 0 from below, then you are a negative value, so you are less than 0. So the limit at 0 from below is 0. What about the limit at 0 from above? The limit at 0 from above is also 0, because when you are tending to 0 from above, you are a positive value, so we are involved with this x. So you see the limit from 0 from the limit as x tends to 0 from below is 0, and also same story applies to 0 from above. So the two limits are the same, therefore the limit at 0 is equal to 0. Now what is f of 0? When x is 0, the function is 0. So since the limit is 0 and f of 0 is 0, then the function is continuous at x equal to 0. Alright, option C is correct. Like we said, f is an even function, so option C. Okay, like I said, we'll just go to question 20. Alright, so that in the next one we just pick up from 21. But it depends if 19 will be long here. Alright, it's not long. The value of x for which sin inverse of 2x is equal to ln 4 is, okay, so sin inverse of 2x is equal to ln 4. What does this mean? So I will give the definition of sin inverse of x. Sin inverse of x is the ln of x plus the square root of x squared plus 1. Alright, so if I want to look for sin inverse of 2x, I just replace x with 2x. I replace x with 2x. Once I square, what do I have? I have 4x squared. Okay, if I take e on both sides, you realize that we just have to equate the arguments, right? So we have 2x plus the square root of 4x squared plus 1 equal to 4. Right, we are taking, if I take e to the ln, I'll just get the argument. If I take e to the ln, I'll just get 4. Now I will subtract 2x on both sides. Okay, so I'll take 4x minus 2x. Then I'm going to square both sides. I'll square, then I also square. I'm squaring with the condition that 4 minus 2x is positive, because if 4 minus 2x is negative, there will be no solution. Why? Because we have a square root here which is always positive. We cannot be equating to a negative something. So if 4 minus 2x is positive, it means 4 is bigger than 2x. Okay, which means that if I divide all through by 4, if I divide all through by 2, I will get 2 is bigger than x. And if 2 is bigger than x, it means x is less than 2. So this is just a condition for me to square both sides, which means if I solve and I have any value that is not less than 2, then that answer is wrong. Alright, now let us square. When I square the square root, I just have 4x squared plus 1. If I square this, I'll square 4 to have 16. I will multiply 4 and negative 2 two times, so I'll have 2 times negative 8x. Okay, because this will be 4 times negative 2, then negative 2 times 4. Then when we square this other guy, we have 4x squared. Now 4x squared cancels 4x squared, so we are going to be left with I'll subtract 16 on both sides. I will get negative 15 to be equal to, when I multiply these two terms, I get 16x. Right, so this means that what is the value of x? X is equal to negative 15 divided by 16. How is this answer like this? It's so weird. Anyways, let's just check the responses. Did we make a mistake? Why do we have okay, no, the negative sign is also supposed to be there. I think most of you are already saying that, oh, I've made a mistake. But anyways, thank God I've realized the mistake because of my answers. So when you multiply, since I put a negative sign here, I wasn't supposed to put it again in the 8x. Alright, so x is equal to 15 on 16. 15 on 16 is a number that is less than 1, so automatically will be less than 2. So yes, response is x equal to 15 divided by 16. Let's go to the options. 15 on 16, option C. And finally, question 20. We are ending this series with question 20, so be prepared to run for the next. A similarity transformation, that is a similitude f on a complex plane, is defined by z prime equal to 3 minus 4iz plus 1 plus I. What's the scale factor? The scale factor is a modulus of 3 minus 4i, which is 9 plus 16 square root 5d. Surely you have not understood what I've said, so I'll explain. Z prime is equal to az plus b. This is a general representation of all similarity transformations. A and b are complex numbers. The modulus, the scale factor, I'll just talk about scale factor here. Anyway, scale factor is equal to the modulus of a, and angle of rotation is equal to the argument of a as well. Okay, yeah, argument of a. Now the center is equal to b divided by 1 minus a. That's the center. Anyways, check videos in this channel for this topic. So in this case, we have z prime equal to 3 minus 4i times z. I think I'm not mistaken. Voila. So it means that our scale factor will be equal to the modulus of 3 minus 4i, which is a square root of 3 squared plus negative 4 squared. That is square root of 9 plus 16, square root of 25, which is 5. Alright, going back to the option D is correct. Finally come to the end of this series. See you guys in the next series with